Just when I thought I would never make another circuit again because I understood the challenge of working with series resistance that's built into coils and caps, I, the forces that be proved me wrong. They brought to me Byron Brubaker, who calls himself MX6 Maximus on YouTube, and we started a conversation, and he inspired me. He sent me some circuits of his that he had designed in Paul Falstad's simulator. Not mine, but in Paul's, because there is some differences. Be that as it may, it inspired me to come up to try again, to see what else. And actually, I already had a hunch what to do, but not right away. What I did was I monkeyed with what he inspired me, and I kept changing it, and then I realized, you know what? I can take the mag amp and graft it onto Eric Dollard's refined LMD, which is what we have over here. Now, Eric Dollard's LMD on page 110 of this link does not specify values, but I learned from experience that, and then also I made some enhancements. What I did was I added another LMD track and then a non-LMD track in between, just purely magnetic. And it's this magnetic core, which is now the core, has to be 4 times the inductance of the LMD track. And this one out here also has to be 4 because this is purely a magnetic. This is a residue of a magnetic amplifier. And so since it's magnetically oriented, it's 4 times the LMD tracks. Now I have this at microhenries because I thought, in my limited wisdom, a long time ago, that microhenries was safe for being buildable. I thought. And then I've gotten criticism since then that millihenry, or that microhenry is not adequate, is not buildable, convenient. And so I thought, well, maybe it should be millihenry because I think that's more common. Be that as it may, I didn't bother changing this. I'm just pointing out to you the ratio differences between them that they have to be, and that I think you can take these up by a factor of 100,000. So the 1 microhenry would become 100,000 Henry, and the 4 microhenries would become 400,000 Henries, and these would be 100,000 Henries. Maybe not as far as that, maybe slightly less, but I think that's the safe limit that I tried. I didn't try to go any higher, I don't think. So I don't know how high you can go. Right, no. Did I try Mega? Yeah, I might have tried Mega and decided... See, I didn't try anything in between. So I don't know. It might be able to go higher than a factor of 100,000. Be that as it may, that's what you increase. Now, there's something that we don't understand since we're only taught one side of the coin. We're taught that entropy rules the universe, and that programs us into being obsessed with always tying our circuits to a voltage source continually. But as it turns out, that's only 1/2 of the situation, and I call it the diminishment or de-escalation, we could say entropic. That's basically diminishing returns. In other words, if we cut ourselves off from the source, the circuit runs down to 0 and depletes itself and uses up all of its stored energy in its various components. But that's only 1/2 of reality. The other half of reality is that it's possible to have a circuit run itself to infinity and explode, and degrade its components or something until it can't rise any further to infinity. So at some point prior to infinity, it will destroy itself. All it has to do is destroy one component in all likelihood. But, maybe not. It depends what component gets destroyed. Once it gets going, if this LED should become destroyed, this portion will still keep running because there's all these subcircuits that are in here that are self-enclosed loops. And this idea that a perpetual motion machine, you have to take the output and tie it back into the input. Well, where's the input? You know, I could put this just about anywhere, this aerial. I could put this load not anywhere. The load has to be in a specific place, and it's intermediary. But the source can be just about anywhere, which kind of makes you wonder what's going on here. Because this is not your normal circuit. This is a circuit that is designed to run perpetually in one of two modes. And it's perpetually only in a potential sense. Because diminishant we go, well, for all practical purposes, for the purposes of describing the situation, it's not a it might be a well, okay, I don't know. It might be a hyperbolic function inasmuch as diminishment to zero may never reach there because it's logarithmic or hyperbolic. In other words, zero is simply an asymptotic limit, asymptote, while infinity is the opposite asymptote. The problem is, of course, infinity is like so far away, but logarithmic growth takes care of that. In other words, the more it grows, the more faster it grows. It accelerates. While in its approach to zero, it may be decelerating its rate of decline, such that it never reaches zero. So this is why I say zero is the opposite of infinity. The magnitude is the same, it's the polarity that's opposite. So in one's complement arithmetic and digital machine language programming, the negative of zero, or the inverse sign value of zero, is infinity, and likewise the opposite of infinity is zero. But they're two magnitudes that are the limits of any system to be able to handle relativistically what is the ultimate limit. Well, it's some version less than infinity, regardless of sign. And so we know in the abstract world of mathematics, we know that infinity is not something you can count. But in the real world of concrete reality, infinity is simply a relativistic limit of any system. We have to redefine infinity depending on the context that we are referring to, that we're talking about, because it's not going to mean the same thing. And I learned this from studying machine language programming when I was much younger, a long time ago, that as far as the register is concerned inside our computer, infinity is simply its limit. It can't go beyond that, and it goes back to zero, you know. Or likewise, when you go to zero, well, technically you can turn around and end up at infinity, but they have a little tweak, and it's called two's complement arithmetic, and that's to ensure that we keep this rigid monotheistic view in a dualistic world, that there's only one zero and only one infinity, and nothing else, it never changes. And that's false. We know yang yin is a situation in which inversion can alternate between opposites. And we know that with AC current. The sign value alternates. So why should we speak any differently of infinity? And it says in the I Ching that if you go too far in one extreme, eventually nature decides, okay, I'm going to invert this because this is too much out of balance. Nature does not abhor a vacuum. That's bogus. She abhors extremes. Whether it's extreme vacuum or extreme fullness, doesn't matter. Either one, she abhors that. And so if it becomes too imbalanced, she'll invert it back the other way. And that's why we have two infinities, two limits in the real world, while in the abstract world of abstract thought, the limit is not countable. You know, that's when we say it's infinite. But it's the same thing for zero. I mean, when you consider that a silicon wafer to make up a computer chip is made of silica but doped with a very minuscule amount of an impurity, the quantity, the choice of impurity and its quantity will determine the behavioral characteristics of that silicon wafer. Well, how far down can you keep dividing a value with respect to another value and never reach zero, but it just keeps getting smaller? That's that, oh, I forget the name of it. Is it Occam's razor? Where you keep having your distance to a fence as you approach the fence, so you never reach the fence, but you keep walking towards it, just at a slower and slower rate. Well, that's a fence. That's what we would consider to be zero, a point on the number line that we can use as a reference, or we call it the ground state in a circuit. You know, what's ground? But when we're dealing with infinity, it's inverted. The closer we reach to infinity, the faster we move in order to make sure that we get there. And that's why growth towards infinity is logarithmically increases. But I suspect that the inverse is the case. When a circuit diminishes, it never fully discharges. It just keeps slowing down its rate of discharge as it approaches the point of zero, the point of becoming fully discharged after it's been running. So this is important to consider because it's two halves of reality for electrical theory. And that means there are two phases possible for a circuit, and that means there are two different ways of dealing with a voltage source. So when we mask the fact, when we try to forget that a circuit is entropic in a phase of diminishing returns, we try to mask that by tying it to the voltage source continually, but you can't do that if it's escalating, because you will drain the voltage source faster than any benefit it gives to the circuit. And so the first thing to become destroyed in that situation will be the voltage source. So I've learned early on in my studies to make a flick switch, just something that flicks, a tiny little ember of energy, and that's enough when you're in escalation mode. So when you start doing this stuff and you start doing a circuit that explodes to infinite gain instantaneously, such as this one, and I don't even flick the switch, where did the power come from? But I'm getting ahead of myself. So when it goes to infinite gain like that, infinite matrix, instantaneously, you've got something. You've got something that's in escalation mode. Uncannily different and opposite to this idea that entropy monotheistically rules the universe with no partner of opposite quality. And that's so bogus, it's pathetic that we still have that as a standard, brainwashing everybody. And it's going to go on for quite some time, because the only way any of that's going to change is when the corporate world disappears overnight, and all the people who support it, or all the people who don't do anything to change it. The non-good Samaritans that are not evil, they just don't do anything to help the situation at all. They just go along with whatever is in vogue. They're not going to be able to deal with this either, because they're making no move on their part to try to deal with this other half of reality. So that's a lot of people on this planet who will disappear in order for a change to happen, because they're offering all the resistance, or they're not bothering to help. Further, a more fuller way of looking at things. And that means it's going to have to be pretty lonely before we can spread this knowledge without any resistance whatsoever to anybody who's willing to listen. Yeah, obviously, we'll still be specialists. Nobody has to be doing the same thing. I don't think we'd want everybody to do the same thing, because you can only do so much. And if you try to do everything, then, well, or if everybody's doing just one thing, then who's doing the laundry, So we do have to have maybe the robots, okay. But we do have to have some kind of a focus. So whoever is willing to listen, whoever is in charge of the subject matter will be open to it. And they won't be closed-minded to it, because we won't have the corporate mentality, the vested interests mentality, which is basically big business, trying to impose their point of view everywhere within our society. The media, our educational institutions. When you hear everybody say the same thing, you think it's true, and the opposite or anything else, contrary, it's got to be false. Because, oh yeah, those fringe people, there's just a few of them. Well, that's how many people will survive, because those are the ones who are willing to share and not demand payment in return for services or products rendered. And that's the kind of world we're going to have. We're going to have a few rich people, but the dominant economic group will be the middle class. And the middle class will not have any money because they won't need it, because they won't have that kind of mentality that they demand money or else they will withhold products or services from you. That kind of mentality just won't fly. It's not humane. It's not humane at all. Nature doesn't do that. She gives you, the bounty of nature, and then we steal it and then charge a profit, which is totally against natural law. So when you have an escalation such as this, and it's instantaneous, you know you've got escalation as opposed to entropy. And I know that because I didn't even close the switch, so now I can catch up with myself. Where did the power come from? Well, when you raise the inductive values of all of these transformers, you find out that only one half of the circuit comes on and then goes immediately to non-infinite matrix. And we know that because if I take a component and then click OK, then we can put and hover over, and we find out it's the diode. Not now. Right now it's some other component will have reached a very high figure. But, oh, there it is. This diode reached infinite watts and infinite amps, and not this one. So this is the one that shut down the circuit, because nothing else has infinite value. This is the one, not even the one alongside it. But I found that in the course, but you see everything is lit up, so everything has a charge. But I found in the course of raising the inductive values here, remember we didn't flick the switch once I turned the simulator on. But as I raised the inductive values of all the transformers equally at the same factored rate of increase, I found that only this half of the circuit lit up when it shut down. And that's when the LED had infinite watts and infinite current. Now you won't get this in Paul Falstad's simulator because he puts an arbitrary cap on all diodes, which probably includes LEDs, I don't know. But at least the diodes, because I had to change it because it was bugging me. It was getting in my way. Diodes are great for accentuating gain. They don't manufacture it, but they accentuate it. Just like spark gaps do not manufacture it, but they do accentuate it. And there's another component. Oh, what is it? Diodes, spark gaps. I don't work with transistors enough, but I think transistors are like diodes. They do the same thing. But there's another one. No, I can't remember what it is. But at least those are two off the top of my head that I can remember. Diodes and spark gaps. So they are not essential. But if you want to magnify gain, that's what you use in a very certain way. It has to be in the right place, in the right direction, and then you'll get an enhancement of escalation. That's why Paul Falstad placed an arbitrary limit on the current going through a diode, because he found from experience that at least in the world of the simulator, they can create weird results. He used the word weird. And I would just say, well, that's not weird at all. That's the other half of electrical engineering that he was not taught when he went to Harvard. Harvard, of all places. You would expect, no. Just the opposite, because it's a big institution, and so it's going to have vested interests monitoring what they teach. Hey, you have some professor there teaching what I'm telling you? How long is his professorship going to last? About 3 seconds, maybe less. It's how long it'll take to threaten him. And we'll take away your tenure. They probably have contracts they signed that, if we don't approve of your curriculum, we can fire you without warning. I wouldn't be surprised. Anyway. So I realized then it's the LED that's the problem You know, here we have something good. It's not a problem. It escalates to infinity, but it does it so quickly you can't use it for anything. So now the LED is the problem. So all I had to do was take out the LED to slow down growth rate. And I did that. And we'll come over to the next circuit that I did in development. 1/2 of a DC Pierce Arrow motor coil. So we have exactly 6 capacitors. All right, we got these two don't count because they're attached to the motor under the hood, and we wouldn't see it. It wouldn't have been noted to have been in the project box of Tesla because all we know are 12 vacuum tubes, which I take to be vacuum tube capacitors. But these two are extra, and they would have been in parallel on either side of each motor coil. And I only need 2 in this simulation to quantify what Tesla did, but each one has its own power supply. Even though it can be initiated by the same source, it has to run independently of the other power supply. And so if we count the capacitors on this side, it's strictly 6. But we have a lot of transformers. We've got 1, 2, 3. We got 6. 6 transformers and 6 capacitors. Huh, what do you know? But remember, this middle core is magnifying the magnetic component of electricity because we always have to give a little extra boost to magnetism because it's always the first one to depreciate and kill the whole circuit. When it disappears, the electricity disappears and you're stuck with electrostatics. And that's not what we want. We want electricity. So I'm envisioning a 2-coil motor. But in this particular motor, it's a DC motor. It's not AC. Because of series resistance, I couldn't do what I did before. When I did... Oh, where is it? No, it's not there. It's here. This one. I can't do what I did here and have this thing give a nice AC or DC to AC inverted, into sine waves. This is not... No, that's not the right one. So this is putting out DC, but because of these diodes, it turns into an AC situation. Well, I don't get to do that. This is without series resistance, because it doesn't work very well with series resistance. So what I'm doing is I'm getting now into the mindset of series resistance, and I'm able to make circuits that work. And I didn't think I could. I don't have any confidence in myself, because I don't have any training, and I'm one of a kind, and there's all these critics who say, oh, you're doing it all wrong. And I'm going, what? There's no such thing as a right way because you don't even know what I'm doing. So in this situation, I took out the LED. So now we won't get infinite growth spontaneously, or instantaneously, actually, is the word I'm looking for. But it does go into escalation mode. And just for variety's sake, just to show you how much it doesn't matter what kind of voltage source you use, and to some degree how much voltage also does not matter to some degree. But what type does not matter. It can be DC, it can be AC, and my headset keeps slipping off my head. Okay. It really doesn't matter. So I chose here to use a 6-volt battery source because back in the old days of the Pierce Arrow car in the 1930s, all cars used a 6-volt battery. They did not use a 12-volt battery because their electrical usage was very small. You had a radio, the headlights, the tail lights, and that was about it. The blinkers maybe, and that's about it. You didn't have all these other gizmos that we have in today's world. And they also grounded the positive pole to the chassis, not the negative. So everything was a little different back then. And also the alternator was to recharge this 6-volt battery was a magneto alternator similar to the alternator in a lawnmower. So you could literally put it in gear and push it down a hill and start the motor even though your battery was completely dead and non-rechargeable. It wouldn't matter. because you could get by. And Aaron Murakami is the one who, I think he's the one, if not Peter Lindemann, it might have been both of them or either one, who relayed this information, because I didn't know this about the very old cars. They were different. Their alternator was different. So you see what's happened in today's corporate world. We don't have that type of alternator anymore under the hood. No, mustn't have anything that's of any benefit to the consumer. No, you got to be tied into the AAA club and, pay money, good money to have somebody come and try to sell you a brand new battery, and you're going, what? I just want to charge. Well, I don't know. It's pretty low. I think you should buy a battery from us. Great. It's a great system. So we started up. Now this is escalation mode, and the only way to change it is to change the direction of this bottom diode. Right now it's in escalation mode, but when I want it to go to diminishment mode, all I have to do is swap the diode. And since I don't know how to swap the polarity of the diode other than having two diodes and having a toggle switch toggle between them, hey, it works for me because the diode doesn't store any energy, so I don't have to worry about it creating a disruptive influence in the circuit. If I had taken one capacitor of 10 picofarads here and another one here of 10 farads and switched between them, that's a major shock of a difference, because one has been, charging even though it doesn't hold much, and the other one now is going to be charging because it's empty, but it holds more, and it's like, whoops, that's really going to create a diversity of behavior when we alternate between the two of them. But since the diode doesn't store anything, I can get away with it, and it works. So let's start it up. Now this is very slow, so you got to be patient, and I slowed down the simulation speed because once it gets going, it picks up speed. And so I wanted to make sure I don't overshoot. But I have to overshoot a little, as you'll see in a minute, because it actually, when it escalates, you have to escalate it higher than what you want it to settle back down to. And it's a little tricky to get it just where you want it. Now the voltage is going to be 3 times the amperage, which means, I didn't start it yet. Give a flick. Which means that we've got an impedance of 3 ohms. It's not ideal to have very high voltage with respect to your current, because I think motors are rated for certain voltages and you can't go beyond that. I could be wrong, but I think that's the case. Now resistive loads are different, but with a motor load they're rated for certain voltages, and that's can become problematic. So this is just a concept circuit. This is not meant to be something to run your car off of, because it still is going to take some tweaks. Now we've got the current and the voltage moving. Now this is what you would call perpetual motion, right? Everything is just doubling back on itself, but it's not maintaining the same rate. There's no such thing as a circuit that maintains the same rate. I've never seen it happen. There's only 2 states, and there's no fence sitting in the middle. You're either going up or you're going down. And there's no middle route to take. It does not exist. I can keep going. It does not exist. The only time you can fake maintaining a state is to oscillate between a high and a low within 2 limits that are reasonably close enough together. And that's my lightning oscillator, but that I did at a time when I had no series resistance, and I'm not going to try to go back to that and redo it, because it took a lot of transitions of development to go from one type of a circuit to another before I got to that stage, that final stage. And I'm not going to go through that again. But I would have to. I'd have to start at the beginning, go back to my first, I recorded I saved all the different stages. It would just be, a lot of work to go through it all over again, and I'm not interested. What's done is done, and I'm going to leave it alone, and you'll see that it only works in what's, more accustomed to, Paul Falstad's version, in which there's no series resistance in caps and coils. But from this point forward, I'm not going to design any circuit that does not have series resistance in it. I'm just not going to bother. So I'm just, from this point forward, things are going to be done differently. And if I can't make it work, then it's a relativistic failure. It's a temporary failure until I know better. And so here I'm doing something I've never done before, use diodes to switch back and forth between escalation and diminishment. I've never done that before. And I must say, it's quite a novel way to get the result I want. To this dual reality of electricity, it either grows or it diminishes, and we've only been taught that it diminishes, and so we have to tie ourselves to a voltage source continually. While here, I just give it a little snap switch, and it's a tiny, I wasn't paying attention, but if you go back to the beginning of the video and watch the amps here, you'll see how much amps, I think it's nanoamps, is all I need to get this thing going, which is commonplace. That's usually the case, either nano or pico or femto, somewhere in that range of about a billion to 1 amps, but that's pretty small. So we're not draining the battery by any appreciable amount, and we got all this energy we get to recharge it with. So no problem with recharging the battery if we have to. Now the voltage here is a band. A low of negative 92 kilovolts and a high of a low of 92.35 negative and a high of positive 91.81. So what I think is happening in here is we've got waves going on, probably sine waves or something, and they're just squashed together, and so we get this green band of color, and we can't distinguish the waves. It's just all smushed together in time, because the time step here is 10 nanoseconds. So that's would be a pretty fast wave if we can't see it, and our time frame is 10 nanoseconds. That's a pretty good frequency of what's going on there in the inductor. Now, here, it's going down. The amps are going down. We can see it. But it's a flat line situation. So that's certainly not AC. It's as close to DC as we'll get. It's not really DC because it's dropping. But then wouldn't DC drop if we're expending the battery too quickly? We'd see the drop noticeably. And that's what happens in my car. It chews up the voltage from the battery pack at a very fast rate because it's a DC-oriented electric car in which current determines the speed, not the frequency, as is the case with an AC motor. So it's really the same situation. So this is basically a DC system now. It's no longer the story that we've been given that it's an AC motor. In fact, I've found, except for the magnetic amplifier, that's the only case that I've been able to fake an AC, and I say fake because it's a DC to AC inverter. I've never really created AC, and I wouldn't know how without a AC generator, or the AC motor creating its own energy, which I don't know how to do that either. So basically, just about most of my simulations are DC. How about that? So I've got a excess. Well, no, this is milliamps. So we're going to have to go up a little higher. Yeah, it's not even a. There we go. So let's just take this up. 3 kiloamps seems to be a nice place to stop. Now sometimes it'll level out and never drop, but a lot of times it will drop. Now if it does, usually I'll get a spike going into the negative here when I toggle over, and I see no spike here, and as it turns out this doesn't drop, and I think it's this negative spike, if you get one, that will drop this a little bit later on. It takes a little while to take effect to hit the amps. So I would think then that the volts are leading the amps, because you can see the spike right away when you close the switch, and then it takes a little while to show up here on the amperage aspect of this inductor that I'm scoping in 2 different places. So you see it is pretty flat. It drops a little. See, it took a little time to drop, and then it's pretty much flat. And now let's reset these values, and we see we got 2.95 kiloamps and 92 kilovolts versus 93. So let's do the math. 2.95, let's see. So that would be, well, no, we have to do it the other way. So, well, no, we have to take the average. So, yeah, what would be the RMS for this? Do we get that? Yeah, it's too high a frequency. It's not going to give it to us, just like it's not going to give us the frequency for that matter. Yeah, it can't. It's too rapid. So I'll just do an arithmetic average, because I don't know the RMS equation, and I'm not going to try to guess what it is. So 92.05 plus 93.39 divided by 2. Alright, 92.72 divided by 2.95. So we've got an impedance of 31.4 ohms. That's a lot of ohms. I mean, that's a lot of voltage with respect to the amps. But I'm not surprised. Actually, that's pretty good, because I've had it in a lot of my circuits far worse than that. 1,000,000 to 1, maybe sometimes 1,000,000,000 to 1 volts to amps. So that's okay. 30, 31, 32 ohms. That's not bad, all things considered. I've seen worse. But hey, one of my circuits, the ohmage is 1 to 1. Which one was that? The volts to amps was 1 to 1. I think it was this one. Yeah, it's this one. But this works only in the non-series resistance simulator, so I can't show you. But yeah, the volts to amps was 1 to 1. That was amazing. I've never been able to do that before. But, it's not realistic. Series resistance is more realistic. Yeah, power factor is unity. So, that's what I managed to do today. Surprise, surprise, I found out an LED is a voltage source. I mean, huh? What? But that's because my headset keeps slipping off my head. What's I don't know why. Here, gotta change the angle. There we go. Yeah, I don't know. Maybe that's something buggy about Paul Falstad's simulator. Why would an LED become a voltage source? Well, some of the reason is because of what's over here. That has a lot to do with it. I'll just show you. I'll take this away. And we turn it on. And nothing happens. Oh, it's not a voltage source. So the problem is the switch is leaking. I didn't think it leaked, but I guess it does. Or else we wouldn't need that. So let's try a different voltage source. Let's try one of these. 5 volts. And we turn it on. And nothing happens. Wow, AC must be very unique. Yeah. So that's interesting. Now see? Infinite watts, infinite amps. So it shows up on the LED, but it doesn't come from the LED. Well, that didn't make any sense. So this switch leaks a little. How about that? So that means that if I were to get a new instance of this, take out the switch, turn it on. Oh my God! It's not the switch, it's the canvas. Oh my God. See, I knew it. I knew the canvas leaks. So it's jumping across. And that might not be realistic. That might be realistic, because when we get some kind of ionization here going on, you know? And how much does it take? This circuit is so powerful, it'll magnify any amount you give it, no matter how small, and turn it into infinity. It's really a bizarre enhancement that I made of LMD's of Eric Dollard's refined LMD, in which it is so powerful and so potent, it's like bizarre. So this is what the schematic looks like. The only change I made here was that I put an asterisk to show that the inductive load is actually connected to here. One lead of the inductive load goes to here and the other goes to here. It just wraps around. And that's what I'm doing. It wraps around here. So I have it going down the center of this thing, not on the two ends. See, that's the way Eric Dollard did the 1988 video, the Borderlands video. He puts the frequency generator at one end of the LMD daisy chain, and he leaves the other side either open, or he puts a resistive load there. And so the whole thing is linear because he's trying to show a transmission line in counter space, namely the space between the wires. But here, I just take that and I keep changing it. I run with it. I don't try to stick to any kind of format. Why should I? So I just go down the middle of the spine for my two leads, because I'm using it for a different purpose. I'm not trying to show off, or test or experiment with a transmission network. Not anymore. Now it becomes my power gain mechanism. And since I've learned how powerful magnetic amplifiers are, now I know to think in terms of magnetism to make sure that it's counterbalancing properly with the electrostatics. Because I remember having a conversation with Mark McKay when I went to my first summer conference in Hayden, Idaho. I asked him, this was in April of 2013. I did the experiment. On a breadboard, I put an LMD daisy chain, several daisy chains, and I hooked it up one end to a grounded aerial and the other end to ground, a separate ground. And I had a voltage difference input of a 0.5 volt, and nothing came out the other end. And so I asked him, I told him that, and he didn't say anything right away, so then I offered my opinion that I think what happened was the capacitance value, overall the net capacitance in the circuit, was dominating too much versus the inductance. And so I was preventing flow from happening, longitudinal flow. Because you need a certain balance between those. Just because the capacitors are in series and the inductors are in parallel doesn't mean you can't pay attention to their respective values with respect to each other. It has to be a certain kind of balance. So he agreed with me right away. Yeah, that's probably what you did wrong. And I didn't have any clue how to execute that opinion. I just never tried. So here in the world of the simulator, I can try very quickly. And that's what depressed me, is because I knew it would be too much work and take too much time, because you have to exhaust. When you don't know what you're doing, you have to exhaust all possibilities. And even Edison was about to give up when he was trying to invent the light bulb, because a tungsten filament was the last thing he tried that he hadn't tried already. And it worked. So, and sometimes that happens with me. I'm tired, I want to go to bed, I'm losing sleep over this, or whatever I'm doing. And then, boom, I hit it, because it was the last option I hadn't tried yet. So nowadays, because of this series resistance, there's not a whole lot of wiggle room to try this and try that, and so I have to play it safe. And that's why I chose this model for my power gain mechanism, and something akin to a magnetic amplifier for my load section of the circuit, this being the dividing line between the two, because I know they work. They're the simplest, the most elegant means of success. So where I go from here, I do not know. I never know. I run purely on inspiration, and if inspiration doesn't come, then I'm just depressed and I don't know what to do with myself. But when inspiration comes, it's like, I think I should try this. And then I get happy and ducky and, oh, I'm trying this, I'm trying that. And it might be a wasted day. It may be total failure and nothing comes of it because the idea just sucks. But this time it worked, and I think it's because I need input from the outside world at this point. I've been doing this on my own for 13 months, and I just can't. I've exhausted my brain's capacity to come up with ideas on my own. So unless I look to the outside world for inspiration, not to do exactly what the outside world does, but just as a point of departure to start from and go from there and develop it in some other direction, it was just something to inspire me, to get me motivated, you know. If I don't get that from the outside world nowadays, I just can't work. I've exhausted myself of the ability to believe that I can come up with new ideas. So this was like, well, this was a gift in a sense, to be inspired by Byron Brubaker to do something different that I've never done before. That I should have thought of it on my own, but I didn't. You know, I didn't want to. I've given up wanting to think up anything on my own anymore. I'm just tired, you know. I've been doing this I'm just tired of it. Day in and day out, morning, noon, and night, you know, few hours of sleep. It's just, you know, only so much a guy can want to do. So that's what I'm living for now, is your guys' and gals' input to me. Because otherwise I'm just dead in the water. I'm in a doldrum otherwise. But it works, you know? So, anyway, I guess that's just about everything. I think I've covered, and then some. Yeah. So you see the controlling factors here was the LED, which is a type of diode, and this bottom diode I chose to have a toggle situation and flip it back and forth its direction. It's now it's going to be all about diodes, I guess, that will control whether or not the circuit escalates or de-escalates. Maybe so. I don't know what the future will hold, but so far that's the picture of reality, because there isn't a whole lot of wiggle room on what to do. I could be wrong, but that's the way it appears. So anyway,